To show this identity, I'm going to make use of the left-hand side. So I'm going to show that the left-hand side can be re-expressed as the right-hand side. So on the left-hand side, we have a sine of alpha plus beta plus sine of alpha minus beta divided by cosine of alpha plus beta plus cosine of alpha minus beta. Re-expressing this is sine alpha cosine beta plus cosine alpha sine beta, and this is sine alpha cosine beta minus cosine alpha sine beta, and this is going to be divided by this, again re-expressing this is cosine alpha cosine beta minus sine alpha sine beta plus re-expressing this cosine alpha cosine beta plus sine alpha sine beta. It looks like very long expressions in the numerator and the denominator, but it can be very much simplified because this and this can be cancelled off, and this can be cancelled off. So in the numerator, we are going to be left with this plus this, which is 2 times of sine alpha cosine beta. And for the denominator, this plus this is 2 cosine alpha cosine beta. And cosine beta can be cancelled. 2 and 2 can be cancelled. We're going to be left with sine alpha over cosine alpha, and this is equal to tangent alpha, which we have proven that it is same as the right hand side. If sine A minus B, this angle, sine A minus B is negative, and A and B, they are acute angles, this will only imply that A minus B has to be a negative angle. So A minus B must be less than 0, which means that A must be less than B. This helps us to deduce that angle B is going to be bigger than angle A. From the previous part, we have deduced that A minus B is a negative angle, and since A and B are acute, we can deduce that A minus B is going to be in the 4th quadrant, since sine of this angle is negative. So if I were to just sketch this angle A minus B in the 4th quadrant, it is going to look something that is like this. So this is the y-axis, and if I were to go for this as the x-axis, so we have an angle with reference to the x-axis, A minus B. And if I were to try to fill in this into the triangle that we can actually form based on this angle, a right-angled triangle, so sine is opposite over the hypotenuse, so this is going to be minus 3, this is going to be equal to 5. And based on the xy axis, minus 3, okay, it is going to be on the negative y-axis. As for x here, we can make use of the Pythagoras theorem. By making use of the Pythagoras theorem, it is going to be 5 square is going to be equal to x square plus 3 square. So x square is going to be equal to 5 square minus 3 square. X square is going to be equal to 16. This tells us that x has to be equal to positive 4. Although we square root this to get plus or minus 4, but based on this, we can see that it is going to be positive 4. And this can help us to deduce the cosine of A minus B. The cosine of A minus B, cosine is adjacent over the hypotenuse, so cosine of A minus B is 4 over 5. In part 4, we're going to start with tangent A plus B, which was given to us as 24 over 7. And tangent is sine over cosine, so sine of A plus B over cosine of A plus B. This is equal to 24 over 7. And this will help us to find sine of A plus B, because from here, sine of A plus B is just simply equal to 24 over 7 multiplied by cosine of A plus B. So it is 24 over 7 multiplied by cosine A plus B was given to us as 7 over 25. So sine A plus B is equal to 24 over 25. By making use of the identity in part 1, we can see that tangent A can also be re-expressed as sine A plus B plus sine A minus B divided by, we are basically replacing all the alpha by A and all the beta by B, divided by cosine A plus B plus cosine A minus B. And we have the values for all these four sine and cosines, because sine A plus B was 24 over 25. We found that in part 4, plus sine A minus B was from part 2. So this is minus 3 over 5. Then divided by cosine A plus B. This was from part 4, 7 over 25. Then plus cosine A minus B from part 3. This is 4 over 5. And if I were to evaluate this, tangent A is going to be equal to 1 over 3, which is what the question wants us to show. To find tangent B, I'm going to make use of this that was given to us in part 4. So tangent A plus B. This is equal to 24 over 7. And making use of trigonometric identity, tangent A plus B is tangent A plus tangent B, which was what we are supposed to be finding, divided by 1 minus tangent A, tangent B. This is equal to 24 over 7. And tangent A is 1 over 3. So we have a 1 over 3 plus tangent B divided by 1 minus 1 over 3 tangent B. This is equal to 24 over 7. Cross multiplying, 7 multiplying over to the other side, we have a 7 over 3 plus 7 tangent B is equal to this multiplied by 24. It is going to be 24 minus 8 tangent B. Bring this over to the left hand side with this gives me a 15 tangent B. And this shifting over to the right hand side, this gives us a 65 over 3. So from here, we can find what is tangent B. Tangent B is equal to 13 over 9.